So you've got an RC excavator and you want it to be a bit more powerful. I have in front of me here the guts of my Huina 1580, and you guys have probably seen my other two videos on the 1580, the original review, which was now nearly 3 years ago, and the upgrade video, which happened more recently. Now the upgrade video was an interesting one because we still kept the original PC board inside the machine, but we took an angle grinder to the arm and cut out some more spaces to install these stronger linear actuators. Now this has actually worked quite well. I also have an electric tool release or tool changer and an aftermarket bucket. I really went a little bit further than I could have and made this nice. After a while I found two problems with this upgraded system. The first problem was the pins on the board in here were too skinny for the female connectors that came out of this. So they were like a JST connector. The hole was too large and so it came out unless you taped it or glued it, hot glued it, whatever. That was fixable. Took it apart, fixed it, no worries. But now this guy still isn't working and I have a bad feeling that it might have been drawing too much current for the board because they are considerably stronger, 60–80% stronger than the originals. As far as RC excavators go, this is how you achieve your motive force. You've either got the gear inside the arm like I just showed you, you've got the linear actuator, this piece spins, and there's like a screw. It's kind of like doing up a nut. Think of a nut on a screw. As you do it up, it goes down the shaft. That's what a linear actuator is. And then you've got hydraulics. Because these hoses aren't connected at the moment, we can actuate it without much effort. So that's these guys. And hydraulics work by pumping oil at one end or the other end of the cylinder. So when it's open, the oil pumps in this end and it pushes the plunger down or the piston down. When you want to close it, this valve's on the other end, it pushes it and goes back up, and oil of course returns the other way. With me so far? Right. Here's a quick introduction to hydraulic systems in the RC world. It's not complicated, but there are a few components that you need to know about. This is a kit that you can buy and you might notice that it actually has a cabin looking shape, and that's not by accident. Most of them actually aren't shaped like this, but that's why this is here, because I actually bought a kit. You need a pump, so you've got a motor that runs a pump that's inside this part. You've got a pressure valve which can turn up or turn down the hydraulic power, or really the pressure, which translates to power. These guys are usually good for about 4 MPa, megapascals. And then you've got a tank, which is also what this fella is. Now, when you buy a hydraulic system, they're often separate, but sometimes they're together like this. An additional extra that is nice in this one is you have a sight glass. There's a tube here. So as you fill up this tank, you can see how high it is. And over time, if there's a leak or if you need to refill it for whatever reason, that sight glass lets you know how much is in there. And that level there will correspond to what's in this tank. Not a huge tank, probably 60 mils or so. The whole thing's not going to be a tank, but some of it will be. And you need a tank because remember I said when that thing goes back, oil returns back in. It needs to return somewhere. That's the pump and oil storage side. Now, as far as moving the oil around, you've got basically what's called a block. Oil goes in, oil comes out, and it passes through these 3 chambers. Sometimes you have more. For every extra attachment on a machine of any hydraulic type, you need a switch, basically. This is closest related to a solenoid. It basically has kind of like a tap at home, kind of. So these little servos turn that figure of 8 tap. It's actually like, it's a channel, is what I should have said. It's a channel. And these are the hoses inside this block. It's all cut from CNC. So it allows the flow, it doesn't allow the flow. Simple as that, right? So if you move it just a little, when you're using your machine, you move it a little and it moves slowly, it's letting a little oil through. When it's all the way there, it lets a lot of oil through, or the full flow. So that's your block. These guys work together. Each hydraulic cylinder gets each end of it connected to one of these suckers. You've got 1, 2, 3 radio channels there. You've got a radio channel here, basically on and off to run the pump. You've got a radio, and the common thing to do is just to flick a switch and the pump turns on. We also have 2 channels, so I've got to cut this up and we've got to use this ESC we had before. We've got 1, 2, turret rotation 3, pump 4, 5, 6, 7. So now we're on 7 channels. Now if we want to have the lights, or any lights, if I want to install them, that'll be an 8th channel, and I possibly will. So I need at least 8 channels. At a bare minimum, you need 7 channels, put it that way. I've purchased a few of these before and I like them. This is... FlySky really makes this the way to go. This is a fantastic receiver to use because they cost about 25 bucks, 20 to 25 bucks Australian, so 15 US dollars. So we're going to have 7 or 8 channels populated on this. We'll have 2 spare. And that will be how we do this. So what do we need? First of all, I want to have a main on and off switch. This comes with the kit. I need 2 ESCs here for the tracks. We're going to need to do some cutting and some soldering. We need the brushless ESC for the outrunner motor for the pump. This is an aviation ESC. It's not 2 ways, it's just a single direction. And while it's adjustable speed, I'll set the radio on full speed, off 0. Simple, right? And then we just need to connect these servos to the radio. And lastly, that includes the turret, which is in this case a servo. It's a 32 pitch gear. Comes with this, the arm comes assembled. The original Huina 1580 is just a little 280 motor with a little gear on it. If you're watching this video now, this actually was a big effort one, this one. Please throw me a like if you're enjoying it, if you appreciate it. If you watched this far, that's worth a like, isn't it? And please subscribe if you haven't. It won't actually change what you see on YouTube these days. The algo takes care of that, but it helps my visibility increase and it helps manufacturers find me because I think not all of them look at the views. Thank you so much for that. Now, let's get to it. First job of the day was to take an angle grinder to these parts here, and I've cut out a number of the bits. Now, when I finished, I came in, I got the pump. It needs to sit on standoffs. So we'll get double-sided tape. I'll line this all up, press it down, and then I'll drill where the double-sided tape indents are from these standoffs. And the rest of it, it comes with double-sided tape, which I think we'll probably use for the most part. We don't need to screw everything down. I will screw this down because it's really quite heavy. And I may drill some holes and screw this guy down as well. He's got a pair of them, so we'll probably use 2 more standoffs under that and bolt him probably back here somewhere. And we just got to get the hydraulic hosing out of that sucker there. From there to the underneath, this is where it goes in the block. Now we could go through a radiator as well if I wanted to, and if I had trouble with oil heating up, that would be worth doing. That adds another 20 bucks American, 30 bucks Australian. You could add that, but we're not going to use a radiator for this little guy. For some of my bigger stuff, yeah, you kind of need a radiator, and the nice thing about this stuff is it's easy to plumb it in. It's really straightforward once you start to understand it. So you've seen all this now. I'm going to pack up all the 1580 stuff that I don't need anymore. Unfortunately, that includes my little army guy who is a double amputee in order to fit in here, and he fit really nicely, but I can no longer use the glass and I can't use the seat anymore because I guess it's now Skynet taking over. It's going to be sitting inside this enclosure, which we can keep. It is designed to fit, so that's brilliant. So let's get, well, I need to get into it. Let's do it. Okay, dog, time to roll. Okay, now we're at the part where I need to solder some bits and pieces. This kit comes with a pair of connectors and inexplicably a power supply. I don't really know why, except maybe to test, but you just need one of these batteries to test. If you want to make sure you've got the right cables for your motors, you basically just test a pair to make sure that you've got it right. And if you get movement from the right pair, then you know you've got the right one. So red and black is for one side and orange and brown is for the other. Doesn't really matter what side is what, because even though I'm about to wire it up without really caring either way what the motor's doing, you can use reverse channel on your radio setup on the IA6 radio, or whichever radio you use, when you're up to that bit. So this is the dual ESC it comes with. It's got all your MOSFETs on the back. I think these heatsinks will be sufficient, so we might just cover it in tape for some insulation and then make sure that when I double-sided tape it to the chassis, I'm using a thick double-sided tape and maybe not the thin stuff that this came with, just to give it that extra little bit of protection inside the metal chassis. Okay, so here's where we're up to at this point. We had a working soldering iron, which is it's done the job. We've got the turret installed with the new servo. We've got the hydraulic arm installed. Don't be like me and cut these too short. These bottom ones I've cut correctly because they will never change their position, but these guys need to be longer so that they can get into the block even when the arm is all the way down, and they don't. However, it's not entirely bad news because the kit does give you a bunch of spare stuff for when you inevitably do what I've done. But I also have some copper piping coming, and I've 3D printed a bender for it. It's 4mm exterior. So all this piping's coming off anyway. We're going to stick a copper pipe on. So that's all right. We've got the pump in, it's got the tank, it's got a little stopper in the top there. The motor spins freely. So we have the ESC for the pump to go. We've got the radio, of course. We've got the tracks, the dual ESC. Now I've already soldered the motor connectors on. I haven't soldered the power connectors on yet. Now one thing this kit doesn't come with is the power wiring and plug that you want to use. I'm going to have an XT60 probably for this. I'm also going to run the negative from the battery plug to the ESCs altogether. I'm going to make a little bus, what's called a bus for the positive, which means I'll have a little board. The power will go from the battery connector through this switch. So I'll drill that and put it somewhere. On the other side of that switch, I will put the little voltmeter, and we'll make it obvious somewhere out of the way so it doesn't break the realism of this thing. And then on the other side of that, it'll have a few soldering ports where we can put the wires from that ESC for the brushless pump, this ESC for the tracks, and probably, I'll probably use a separate BEC, battery eliminator circuit, to power this. Because although this thing has a 2 amp 5 volt BEC, and this one has an unknown BEC, this whole system runs on servos. These 3 servos in particular, and also the turret. And I want them to have access to their full 6 volts the whole time. So I'm going to get a 6 volt BEC that's like at least 5 or 6 amps hopefully, and I'll run that separately as well so that the receiver has the power it needs. Here's where we're up to so far. I've got a bus done. This is the bus that basically has all of the power. We've got our switch, so we've got our power that comes in through the XT60. And the negative goes straight to the negative side of the bus, the positive goes to the switch in the front, and then it goes to the bus as well. Now I probably need to attach it better than what I've done, but that's... Oh yeah, I just didn't screw it in all the way, that's fine. Alright, so we're going to retain our battery compartment. We've got the pump, that's the ESC for the hydraulic pump. We've got the power for the 2 ESCs for the tracks. We've got the voltmeter, and we've got my BEC, which is 6 volt 5 amps. It's the one thing from the RC 4-wheel drive RTR Trailfinder 2 that is actually worth keeping electronics wise. That's going to run all the servos. So the four servos here, the turret and those little fellas. Next, I'm going to piece it together. I'm going to put the copper piping on the arm because I cut these suckers too short today. 2 out of 6 are the right length, so we're just going to remove these and I'll redo them. I've got heaps of spare piping and the stuff I cut off, so we're going to be good. So that is where we're up to. The last thing I'll do is add some weight. The kit comes with some weights, and I also would like to get these tungsten things back in. Oh, they're not heavy enough to be tungsten, but they're heavy. We'll get them back in too, and then we'll give it a test fire. Get the hydraulic oil in and go from there. So this is it for me today. Pardon me, here's an ad. Thank you so much. And I will be back for the next round for you in just a few seconds. Right, well for me it's a new day. I realised before I continue with the copper pipes that I've got here, I shouldn't have soldered the ESC here directly to the board because I want to be able to remove this cover. So I'm just going to get the soldering iron back on, and we're going to just stick a couple of XT30s on this line here, and I'll just add a bit of wire as well. But otherwise I'm pretty happy with the bus. I'm also thinking about where to mount this. I've got to come up with mounting points for the other electronics, and then we're going to get this arm apart. Now, my only problem with these pipes is that they've not been bent with any kind of mandrel bending tool. They've been heated and then seemingly hand bent. They're dented, which means the diameter, the inside diameter of these pipes, wherever they're bent, is a lot smaller. Shouldn't really bend pipes like that. That said, before I sound too judgmental, I've never bent copper pipes in my life. I do have a fairly simple little tool here. It's something I adapted from something on Thingiverse just to make it a bit more friendly. The idea is you put the pipe through, it gets clamped on, which we'll use one of the clamps here. I haven't bolted it together yet. And then you turn it so you're actually bending the tube around that. Some of these bends are like they really flatten the pipe out pretty badly. I don't know if this is the only way to do it, but I've got to think it's not. Anyway, we're about to do some learning, I guess. Let's see what we can learn, and I'll get on with this day. Let's do it. Right. Well, I'm sufficiently aggravated by this silly copper pipe kit. I can't recommend it. Don't buy it. It's got a few problems. God. Alright, so my little bending mechanism works absolutely fine. It's not my design, it's someone else's, but I just adopted it a little. I got good bends and they were the right size and everything, but the problem is the hardware that they include doesn't work out properly. These little jiggers have the wrong hole width for what's on this arm, because you really want everything to terminate there, but these ones terminate way too low. And you can't shorten them unless you cut them and then braze them again, and I didn't want to do that. Although, now I think about it, how hard can it possibly be? I mean, gee, you've just got to cut it. Yeah, look, I just don't recommend it. I just don't. If you're the kind of person like me who doesn't really have much metalworking history, while you can work stuff out, it just ends up being challenging. Don't buy it, it's stupid. I've got everything working now with enough reach, although that's the first time I've tested it. I still do actually have, yeah, everything's good. So I still do actually have all the copper pipes to convert this front little mess into that. But looking at their picture, they even have cable ties around it all. Why would you get a copper pipe kit and then use cable ties on it? I just don't get it. So I'm going to use a hybrid. I've got a couple of pipes, 1, 2, 3. It looks nice enough. Some people would probably prefer the spring cover, all 4 of them there and then all coming up, but you know what? I think that actually looks all right. So now my next job is, really what I should do is test fire it, plug everything in and just do a hydraulic test. Yeah, that's my next job. So that'll be what happens next. So we'll work out the channels, we'll bind the controller. I'll find a home for this that has double-sided tape. And the nice thing is about the bus that I did, which is under here, is that everything's modular. So I've got my connectors for the track ESC, like for each side of this. That's this fella here. The tracks are ready to plug in. I've got 2 other outs, power outs, one for the BEC and one for the voltmeter. We've got the XT30, which is for this fella, this guy that powers the pump. And then we've got the battery compartment, which I've managed to retain by cutting half of this out, and the battery will live in the same place as usual. And if I need to put one little shelf under it or something, I still can. So we're actually not too far from being ready. I think the next thing really that I need to focus on is just getting the radio set up. Right, I'm going to do the next bit, and while I get that ready, this video is brought to you by my channel members. This is the RC-TNT scratch build guys. They chip in monthly to help keep this whole thing running. Thank you so much, scratch build guys. I really appreciate you guys. There are 3 tiers. They're the top tier, and that gets your name here. There are 2 other tiers. The top 2 tiers get to see this video before everyone else, and the bottom tier gets the warm fuzzies for supporting me, and there are some custom emoticons for when we go back to doing live stuff again, which hopefully isn't too far away. Right, onward. We're actually not too far from being done now. It's getting exciting. Let's keep going. Okay, well, here's where we're up to. I haven't stuck any of the electronics on yet. Right now we're just going to do a test fire and make sure everything works. I haven't stuck the oil in yet. I've just got number 46 hydraulic jack oil. Hydraulic oil comes in different consistencies and it has different additives and stuff like that. This is a good basic one. It's like Penrite's an Australian brand, but it's just one of the quality ones. I've actually got a 5 litre bottle in here as well, but I've used this one before with my models. This is roughly the middle of the 3 viscosities. 46 seems to be what they recommend on the internet, so that's what we're using. Quick note on these copper things on the pipe kit: if you're following along with me, don't buy this, it's a waste of money. If you have brazing skills, do it yourself. Highly recommend that. If you are looking at the kit and thinking, oh, that would look nice, yeah, look, I guess so. I've used 3 of the pipes in total. The bends were just not well done. They didn't use a bending kit. Like my bends are done with the tool that stops the thing from going wider and crimping. These weren't. They were just done with pliers or something. It's so dodgy. Also, it's too long. I need it to be about 40 millimeters shorter, and I could make it shorter by doing some more like bends here. I suppose I could bend it down and then along, then up again and then down, just to shorten it, because each bend shortens it, right? But I just kind of had enough of messing around with it. So I'm only using 3 of all the ones it came with. I've had enough of it. The thing looks pretty good actually. So this is the electronics as they currently stand. Everything's plugged in. I'm about to bind the radio. I've got the bind plug in. I've just, let's stick this in and see what happens. Power's in. Will we get magic smoke? I sincerely hope not. Power's on. I think yep, we're bound. Look at that. Okay, now we turn it off. We unplug the bind plug, put him back on. I'm not going to keep this I'm not going to keep this camera live while I do this because there's going to be a bit of fiddling. What I'm going to do, here, let me just turn this off. What I need to do now is work out what channel I'm going to plug everything into. That's going to take a little bit of thought. I've got to work out how I want to do this, because on this little radio here, you've got shoulder controls, which are really good for doing the tracks. They're variable, so that's perfect, right? So I'm going to have to program it. So there are 2 dials. I can give them a channel. I'll make sure that this little thing is plugged into the correct one that corresponds with this. You've got buttons on the back here, which I'm not going to use for anything for now, although you actually could make the turret, honestly. You could make the turret like that, but I'm actually not, because I'm going to use, this will be the turret, that'll be the stick, which is this little fella, this will be the boom, the big guy, and this will be the bucket. And that's pretty much it, so let's get to it. Now this cost me, I think, 6 or 8 Australian dollars 6 or 8 years ago. It's got a fairly broad tip on it, but I did all the soldering for this yesterday using this very cheap iron. 2 to 4S LiPo, I think it is, or 2 to 3, whatever it is. You don't need a crazy high-tech iron like this for general work. Even smaller stuff like this, you don't need it. But this has a few little nice features that, if you have the extra budget for it, this is still, like, it's still not overly expensive for being a full-featured iron, particularly with exchangeable tips. You can change the tip on this guy. You unscrew it and it'll probably even be fairly standard. You'll have the heating core inside there, yep, and just one of the many tips available. So you can change the tip on something like this, but there's no temperature adjustment. You get what you get, and there's no sleep. So it keeps drawing full beans, full power the whole time. So basic, right? Definitely does the job. There's a link in the description for one of these. Really, this plus one of these guys, it's like steel wool, but steel wool doesn't work. You need to use this kind of thing. I've tested steel wool. And I use a nice fat soldering, nice fat solder, because it has a nice big resin core. So they're good. For the really fine work, you want smaller diameter stuff, but this is what, 1.2 or something? Just, it's 1 mil diameter. I find that really good for general purpose. These things together, you're sorted for soldering. If you want to get a bit more special, a wire stripper like this is indispensable. I find tweezers very useful, and a nice, even cheap, flat flat wire snips. They've got to be flat on one side. You get a nice close cut when you cut. So really, there you go. That's all you need for a good basic soldering setup. Heat shrink, and I use this guy all the time as well. It's just a basic hot air blower. Now we're getting a little bit more fancy. This, a nice silicone work mat, and a resin in a little bowl or a container. You can dip wires in that aren't taking solder properly. You just dip it in there, and then the solder will just flow beautifully. These things together work very well. You want to step up again, something like this, beautiful. Or just get a nice mains powered thing. I'll put a link to all my favorite soldering gear together. This is all coming from me reviewing the Secure portable unit. I really like this thing. There are going to be many use cases for it that are just absolutely perfect, and for everything else, the cheapie's fine. So that's soldering out of the way. Let's power this sucker up. Well, my problems continue with the tracks. I can't get it to work properly. There's something janky here. I'm going to try another of these same radios. Maybe it'll work, and if it doesn't, I've got a different radio coming, and I have another large receiver I'm going to try. I have another receiver of the same model to try, the IA10B, and I also have a really old Turnigy unit that's only 8 channels, but it'll also work. It's AFHDS2, so we've got a few things to try. But before I muck around with that, I thought we might just get the hydraulic fluid in, because we can test everything else, and I can come back and stuff around with these tracks in a bit. So that's what we're going to do. We'll leave the tracks unplugged, and we'll just do the rest of it. So we've got that plugged in, we got this. Now, this will turn the pump on, but we don't want to run that dry. So we're going to put the fluid in now, and at least I'll have that done. It's a teeny tiny little hose. I could make a filler. How lazy do I want to be here? I haven't cut this open yet. I've just been unscrewing it, but that's actually going to work. We might just do that. I could drill it, I could try and stab it, I could cut it. So many exciting ways to damage it. What if I just ruin my nice tweezers? Because why not? There we go. I'm going to regret not having paper here, aren't I? Yeah, I am. Fine, we'll stop. Aha! Thought I had some. Right, so what we really want to do is get a hose into it. Yeah. Don't be lazy, Craig. So what we'll do... Oh, I could just use a syringe. I've got the syringe here. Oh, it's got a filler thing. That's interesting. All right, let's give that a go. It's got like a needly looking thing. Come on now. Look at that. That's a nasty piece of work, that is. Bloody hell. That's really sharp. You do some damage with that. I did myself a mischief already. Ouch. I don't know why I felt like I should stab it then, but I did, so I did. Big brain genius hour, that is. Goodness gracious me. That was dumb. Don't be dumb like me. Can't believe I did that. I know better. I know better, but I didn't act better. That was just silliness, that was. All right. Now we've got a sight glass in here, a filler. I'm just going to put that down in further so I don't get it everywhere. What have we just put in? We just put in like 10, 12 mil. All right, there's another 20 mil. I'm just going to clean that up. Quite a decent diameter on that. It's like 2 mil. I mean, I put a decent hole in my finger here. It's peeing blood. Gee. I'm not always the brightest spark, am I? I don't know why I felt like I needed to test it, but I barely touched it. It went straight in. It was medically sharp, that is. It's quite a sizable tank, really. I've seen nothing in the sight glass yet. So what I'm going to do is run the pump in a moment. And we'll just see what we can see. Get rid of that. All right. We're still bleeding here? No, we've clotted. I'm really grateful for some of the bodily functions we have, like clotting. Yeah, it seems to have clotted finally. That was a shocker, that was. Oh, okay, now we're starting to see, I'm sorry this is a bad camera angle, but you guys can't see the sight glass. I'm not going to fill it all the way to the top. We're going to, I don't know how full it should be actually, but like this entire install, I've kind of made it up as I went. Now that sight glass, it's just a clear tube. It's now just filled to the top, so it's about a finger's width from the top of the thing, top of the tank. I might just wipe that, pop the lid on so it doesn't feel like it needs to fly out. Now let's see what we can see, eh? Oh, we're going to need to add more actually because the cylinders all need to fill up. All right. So the sight glass should go down. All right, so already, just gonna bring that down. All right, already the sight glass is empty. Because remember, we're not just filling the tank, we're also filling the cylinders. 1, 2, 3, 4 cylinders. So there's actually quite a bit to fill here. So it's going to be something like, I don't know, 90 to 100 mils. The tank is a 60 mil tank, I think. If you haven't realized this, I'm making this up as I go. There are no instructions. There are probably instructions. I haven't looked for any. I've just built the thing. I mean, there aren't a lot of parts to this thing, so it's not exactly rocket science. But I've also never built a hydraulic anything before, so we're kind of gonna learn on the job, so to speak. Alrighty. So we're gonna add another 20 mils, but probably not all at once. Because once that sight glass starts to fill up, I'll stop and do the next cylinder. But I just did 2 cylinders at once then. And now the sight glass is starting to show. Okay, we are going to do it all at once. Not the next one though. Might just take 10 or 11 mil. All right, we're seeing that fill now. That's good. Sight glass is empty again. Oh, hang on, I still have more in there. just 5 mil. And it's showing, so we'll add a bit more. I think we're going to need another 20 in total, but the cylinders are mostly full, which means all the pipes are mostly full. So we're just about there now. I've just got to work out these tracks. Then we'll have a hydraulic excavator from the 1580. Isn't that cool? I'm just going in bit by bit because I don't want to just overflow it. There are also going to be air bubbles in this whole thing, so it's going to take a little while for it to all settle. Again, I'm just making it up. I'm guessing as we go here. He's ready. All right, we're done. We are done. She's a noisy little thing. We'll stick that back on. We don't want to stab ourselves any further. That was a nasty. So there we go, one hydraulic excavator. My next job now is to troubleshoot the radio system. I don't know how to fix that yet, but we're going to work it out. That sight glass is very handy. What are our volts looking like? Yeah, all right. This little LiPo is going to need some power as well. Anyway, there we go. That's quite satisfying. So we'll stick the little lid on that. Now I'm going to leave you until I work this ESC system out. I don't know what the problem is yet, but I'll work it out and I'll tell you what it was in just a minute. Be back in a while. Finally, I've worked it out. So this is from my wheel loader, and these on the wheel loader toggle switches and sound, so they're basically 0 max, 0 min. There's no setting in here that changes it from a switch to a dial, and maybe it's a firmware that's been custom loaded because this came with an RTR from China. No idea what's going on there. It so happens that I have another one of these that came with another RTR from China, but instead of being a wheel loader, this came with an excavator. And what do you know? These work for tracks. On the excavator I've got, on the Liebherr, the 112 white one I've got. So I copied all the stuff I'd done from the other one onto this. Not a single setting is different, and now, here we go. It's working. Blowed if I know why, otherwise it must be custom firmware. I've got no idea. So now that we have a working machine, I've actually set it up so that we've got 2 speeds for the pump here. Maximum and just a lower, although I don't like that resonance. This is a really basic radio. You can't really change much with it, but let me just show you. It works, right? So now that that's all working, oh, hang on. There we go. So now it's all working, I need to find a home for all of these separate pieces, get it together, get some mass into the back of it, because it really needs a little bit of ballast, and really even more than this if I can find something. A couple of nice heavy blocks of metal would be really good. And then we'll have it together. I'll have a hydraulic excavator, so hooray. One last time lapse, that'll be to get this thing together, and then we are done finally. I think I wasted about a day on this yesterday. Must be custom firmware. I don't know. I've got a proper device here somewhere, which we need to set up. It's a, where is it? When we do the excavator roundup, we're going to use a digital force gauge, which I need to mount to a plate, and then we can actually do some accurate measurements on what it can handle. That's not great for my scales. I'm going to guess this thing can lift around 7 kilograms. What are the odds of that happening? Let's just see what this thing weighs out of curiosity. Bang on 7 kilograms. That's with some extra mass added to it, and yeah, I reckon it can probably lift. I'm going to downgrade that to probably 6-ish. It's certainly a lot more than the stock Huina could do, but it's still not a particularly accurate way of measuring. So we'll use the digital force gauge in a future video. I'm pretty happy with this kit. What I'd like to see changed on the kit would be nothing. I'm really happy with the kit now I think about it. The kit actually cost about the same as the excavator, but that still makes this easily the cheapest hydraulic, the cheapest way into hydraulic excavators if you're so inclined. Yeah, so I mean, look, you've seen the process I took. I made that up as I went. There probably are instructions. I haven't looked for them, but I'm sure they're out there. Obviously, some tools are needed as well, but it was a fairly straightforward process. And I mean, the one thing that you're going to miss is having your driver and whatnot in here, because now you've just got the pump. Oh, she's heavy now. Yeah, I'm actually very happy with it though. I'm a bit disappointed about that copper pipe kit, but I actually don't mind the hybrid here as it is either. It's a small, compact and very cool hydraulic excavator. I'm very happy with it. So there you go. You've just seen in mostly time-lapse the journey of how to go from start to finish. It was somewhat involved, and look, I did lean on a fair bit of my experience to make it happen. I also made my mistakes, and you know, I also didn't use everything they supplied. There's a bunch of stuff still in here. I didn't use their double-sided tape. In hindsight, I could have actually used the included ESC, because it turns out it was a radio problem. It was my end all along. So if you want to get into hydraulics and you are considering spending Huina 1680 money, the last thing I'll leave you with is this little top tip. We are going to do a full comparison in the not too distant future. I've got a bunch of excavators here. This is the WL Toys 16800. It is basically a 1580. I can tell you that it's considerably cheaper than this. It was about 65% of the price of this. So 16800 from WL Toys plus the hydraulic system, that'll send you home with a hydraulic excavator for about 1,000 Australian dollars, or whatever that is in US dollars, 600 bucks or something, I don't know. Anyway, we'll have a look at this when the time comes. We're going to use this force gauge to measure everything from the cheap to the very expensive non-hydraulic ones. And we'll include this guy now for fun because this would have been the same stuff. So I figure, hey, now we've got something to actually compare it to before and after effectively. Well, this was intended to be some B-roll for the after, to say, hey, look how well it works. But what I'm finding is the tank is actually really warm. It stopped, well, there are a couple of things to tell you. First, I've changed to the ISO method of control here, and I thought I'd better actually learn that. I've got to unlearn everything I've done with my other excavators. So this was me basically starting fresh with new directions for the controls. Now these cylinders are actually warm-ish. Nothing's leaking as far as I can tell. I've got a 3-amp battery in there, and the block is really quite warm. The tank is hot. That tells me that even though this has a fair amount of oil in it, which is good for keeping it cool, right? It still needs a radiator. Now the good news is you can buy, I mean you could probably make it too, but you can buy a radiator that's got the fins and the thing that goes through it and a fan on it. They're like 35 Australian dollars. So even less in American, it's like 2/3 of your dollar. US is $1 Australian dollar. So they're like 20 something dollars, the low 20s. My 3-amp battery is warm too. So what I might do next for this project, I don't know if I'll get it on video, but I might redo the wiring and make it so it's all neat, because it was a bit of a dog's breakfast in there. And I'd also like to get a radiator fitted in, maybe even cut out an area for it to be able to breathe, because this gets hot after just that amount of playing. I was working it hard but I noticed that this piston here stopped functioning, and I suspect because there are no leaks, it simply is that the oil got too hot. Thank you so much for bearing with me. This was a bit of a journey, this one, but that's the nature of this kind of video, isn't it? Again, thank you to my channel members, the scratch build guys I showed before. Here they are next to me again. Thank you so much, guys. Please throw me a like if you enjoyed this one. I welcome you to subscribe to the channel, and it's not going to change what you see, but it'll help increase my profile with manufacturers, so thank you very much for that. If you have any questions, throw them in the comments. Please look in the description for everything relating to this. I'll put a link to every single thing I can find. I'll prioritize Amazon because that's probably going to be easier for United States people. There'll be an affiliate link for all those things. So it'll also give me a small kickback. I don't know what it is, but it'll be small. But it's there, just letting you know. And yeah, comments, questions, your own stories, all welcome in the comments. I read them all. I reply to almost all of them as well. Share your story, tell me what you'd like to see, and I'll look forward to catching you again right here on RC-TNT. Cheers.